One of the applications of the sum and difference identities that we've learned is we can now do pi over 12 questions. We can add that to our unit circle and we can figure out all the pi over 12 values without our calculator. The strategy for that is we're going to use values that we know already on our pi plate, like pi over 3, pi over 4, and pi over 6. So what I've done in the brackets there is I just wrote what is pi over 3 equal to if you had a denominator of 12. What is pi over 4 equal to if you have a denominator of 12, and what is pi over 6 equal to if you have a denominator of 12. And then we're going to use those to add or subtract to find the value that we're looking for. So for example, for pi over 12, how could you use these ones, adding and or subtracting, to get pi over 12? 4 pi over 12 minus 3 pi over 12. Perfect. Can you see another way that you could get it? 3 pi over 12 minus 2 pi over 12. So there's sometimes going to be multiple ways that you can make it work to find the value that you're looking for. So if you said pi over 12 so if we're looking at 4 pi over 12 is minus 3 pi over 12 is equal to pi over 12, we can write cos of pi over 12 as cos of pi over 3 minus pi over 4. If we write cos of pi over 3 minus pi over 4, we're writing that like a difference identity. And so pi over 3 becomes our alpha, pi over 4 becomes our beta, and we can plug in pi over 3 for alpha and pi over 4 for beta using our formula, and now all of those values are on our unit circle. So even though there's 4 of them and the equation gets quite large, we can calculate each one of them, and then if we simplify our fractions as we go, we get root 2 plus root 6 over 4. Part B was sine of 75 degrees. Now 75 degrees in radians is 5 pi over 12, but it doesn't matter. You can solve this question also with degrees. Can you think of two values on your pi plate that add up to 75? Well, 45 plus 30. And again, the first one's your alpha, the second one is your beta. So I'd like you to plug that in and calculate a final answer for sine of 75 degrees. Once you're done, you can look up to see how you did. These first two examples, you were able to get them using just things from 0 to 90 degrees or from 0 to pi over 2. We can also use any values on the pi plate or any coterminal ones even beyond 1 revolution. We're going to do one more example. So for part C here, we're going to find the exact value of cos of 17 pi over 12. Now, before we solve it completely, I'm going to see if each one of you can come up with a different way of adding two things or subtracting two things that are on your unit circle to get 17 pi over 12. Okay? So once you think you found one, let me know. I'll write it up on the board. But I want to see if each one of you can come up with a unique way of adding up to 17 pi over 12. Now, this is a good list that we've come up with so far. I want you to look at the list and see if you can find a pattern. What has to happen in each one of them? What is always there? Well, yeah, they all equal 17 pi over 12, yes. There's always a pi over 4. Is there always a pi over 3? No, we have some with pi over 6s. But do you see that each one of them has a pi over 4 somewhere? In fact, if we were highlighting those pi over 4s, here we got 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. We have negative pi over 4, negative 3 pi over 4. Can you tell a pi over 4 we haven't used? We haven't used negative 5 pi over 4. Okay? So over here, negative 5 pi over 4, that's the same as negative 15 pi over 12, right? What would you have to add to negative 15 to get to positive 17? You'd have to add 32 pi over 12 to make it. If we reduce 32 pi over 12, it'll always be something on our pi plate. 32 can be divided by 4. Divide that by 4, you'll get 8 pi over 3, which is on your pi plate. It's more than one time around, but it's coterminal with 2 pi over 3. So what we realize is if we're trying to find 17 pi over 12, you can always start with a pi over 4. And it doesn't matter which pi over 4 you start with. Some people always like to just start with pi over 4. That's 3 pi over 12, and then say, I'd have to add another 14 pi over 12 to make it work, and then reduce that and find out what family member that is. Some people like to try to get as close to 17 pi over 12 as possible, so they might choose 5 pi over 4, because that gets you to 15 pi over 12, and then you just need to add another 2 pi over 12 to get there. But no matter which one you choose, they will all give you the same answer. So for example, if we chose 21 pi over 12 minus 4 pi over 12, because that makes 17 pi over 12, and we reduce those, the first one is a pi over 4 family, 7 pi over 4, and the second one is pi over 3, and plug it into the formula. Now we have to be careful because some of these are going to be in quadrants where sine or cos are negative. But plugging those values in, once again we get a root 2, a root 6 all over 4. So what you're going to notice for your pi over 12, for sine and for cosine, is that once you've simplified it, you will always get a root 2 and a root 6 on the top. What's going to change is sometimes one of them is going to be negative, sometimes both of them are going to be negative, and we've seen that sometimes both of them can be positive. And you will always be dividing by 4. So it's a way to sort of recognize if you've done the pi over 12 correctly, if you have sine or cos. Then sometimes for these questions, they ask as a part B, you just figured out cos of 17 pi over 12. What would secant of 17 pi over 12 be? And all you do is take that fraction and flip it. For practice, your pi over 12 questions, you can do example 7 or homework example 7.